Beat. All right. So we're going to do systems of equations. What is a system of equation? It is a set of two or more equations. The solution is your X and Y combination, or tomorrow when we do the XYZ, it would be an XYZ combination, okay? That is true for both equations or for all the equations. So that is true for all the equations. Okay, so a system, a set of two or more equations. That is true for the XY pair being true for all the equations. Okay, there are three ways to solve a system, three ways. And you've got to know how to do all the ways. And last year with Miss Davis, she probably did graphing the first day, then elimination method the second day, then the substitution method the third. And guess what we're doing today? All of them. That's right. Welcome to PreCalc. You should know this. Okay. So let's start with the three ways to solve. With first way. Move this down. So the first way is graphing. Most everybody knows how to graph. And so here's your system. They'll do 3x minus 2y equals 6 and x plus y equals -2. And what you have to do to graph is you have to set it equal to y because you have to graph a line and you have to put it in your calculator, obviously. So solve this for y. Let's see, this would be -2y equals, I like to put my x first because that's my slope. -3x plus 6, divide by -2, divide by -2, divide by -2. Y equals +3/2 x. What is that? -3? So set that equal to y. And then this one, this is much easier. What's that equal to y? Good job. And then if I give you no calculator, which I actually think I am letting you use the calculator for this one. Why? Why am I letting you use the calculator when you should know how to look at this? Before we use the calculator though, do you know where to start graphing on this without a calculator? Where would you start it? So -3. -3. Yes, -3. And then you go in what direction? Up 3 over 2, up 3 over 2. Okay, so you start at -3 and you go up 3 over 2, up 3 over 2. This one you start at -2 and you go down one right, or up left one. But let's just look at this real quick. So you go to y equals, you type in, I always like to put mine in parentheses, so 3/2, but I think you all know the fraction button too, -3. And then y2 would be -x, don't put minus, -x minus 2. Zoom 6 is your standard view. Mine takes forever, by the way. The color, my old color one takes forever. There it goes. Come on, honey. You can do it. All right. What's the famous phrase that'll get you that intersection point right there? What does she say? Second Cal 5 enter. That's one of the 26, y'all. Second Cal 5 enter. Gosh, I'm going to miss her. I miss her so much. Second Cal 5. First curve. Enter, second curve, enter, second, enter. And there's your intersection, 0.4, -2.4. Okay, that's not what I have in my notes. If I had gotten two parallel lines, what's your solution there? It's not intersecting. So there's no solution. They have nothing in common. No solution. If I had gotten a line and then the second line was graphing and it landed on top of it, do you know what your answer is there? All reals. That's right. Okay, they're called coinciding lines. I have literally drawing marker all over me. Right. So that's your first step. I would never do graphing if this was like, I don't know, if this number was a fraction too. I only do, if it's easy to solve for y, I would do graphing. But other than that, it's usually my least favorite thing to do. You also need to remember that you could do a horizontal lines, y equals 0, okay? Or vertical lines would be an x equals. if you have to do the x equals line, do you know where to go for that? Your apps program is on. It should be on. See where it says inequality? Did she show you this app too? And if you hit that, you can actually go to an x equals right up in that corner. We might be doing that in a moment anyway. So, but you would go into the right there, hit enter, and you could type like x equals 0. You cannot type an expression in here. You cannot type like x equals y plus 5. You can't. You can only type x equals a number in this one. All right. So we'll get to that in a minute. So that's the first way, graphing. Let's do the second way. Good old. This is the second way that most people don't like. I like it. I think the SATs love it. Substitution method. So let's do 2x plus 3y equals 9 and 5x minus y equals 14. And I want to do this by the substitution method. The only way you can do substitution is if you solve one of these for one variable. You have to solve it either for x, one of the equations, or solve it for y. It doesn't matter. So solve for one variable. And you definitely don't want to solve it for something like, I definitely wouldn't solve it for that x. There's a 2 in front. I wouldn't solve it for that y or that x. I'd solve it for that guy. He's all by himself. So get y by itself. So I'm pretty much switching these two. So let's see, it'll be 5x minus 14 equals y. Then what you do is, since you solve the bottom one, you take this expression and you plug it then into the top, not into the bottom one. You'd get a like negative 14 equals negative 14. You just get stupid. It's just stupid errors that I see all the time, precious lambs. Plug this into the y or x, y or x, y or x. Which one? Y, because that's what y equals. So you rewrite this top equation now. So you have a 2x plus 3, comes the rain, times, and now instead of y, you replace it, you substitute it with 5x minus 14 equal to 9. This is the substitution. I subbed it back in. I took the bottom one and subbed it into the top, or you could take the top and sub it into the bottom, okay? And you need to practice these. That's why you have homework on this. Don't just let photomath do it. That's why you're not getting good grades on quizzes. What is this? 42 minus 42 equals 9. 17x equals, add that over 51. X is 3. Once you get x to be 3, then you plug it back in. I would plug it back into this one because it's already solved for y. So 3 times 5 is 15 minus 14 is y equals 1. There's your point. 3, 1. That's the common solution. Okay? If it ended up where you would have a number equal to a number, if those two numbers are equal to each other, then you have all reals. You have parallel lines then. Okay? You remember that? Substitution method?
Yeah.
What?
I don't remember.
You should. Good. Good. It's on the next quiz. All right. Then the one that you all probably do enjoy is this third one. It's called the elimination method. And its name is what you do. Down. The elimination method. So let me give you a problem and we'll do it. 2x plus, I got to write these correctly or else it'll come out as a weird fraction. Here we go. Okay, so the elimination method is you want to either eliminate the x's or the y's, and it really doesn't matter which one ever you want to eliminate. I usually choose the one that has where one is negative and one is positive. If you choose it, though, this y, you could still get rid of it. And what you do is you pretty much flip the coefficients. So you take the top, if I'm going to get rid of the x's, let's say I'm going to get rid of these x's. So you take the bottom's coefficient and you multiply the top by it. And you take the top coefficient and you multiply the bottom by it. If they were not negative, though, if one of them wasn't negative, you'd have to make one of them negative. Okay? So like if I wanted to get rid of the y's, I'd multiply the top by 7, the bottom by negative 10, something like that. It'll still work out. Once you do that, multiply the entire equation by 2. So let's see, this would be negative 6x, this would be 20y, and equals 10. Everybody always forgets that last part here. The bottom would be 6x plus 21y equals 72, yes. Then once you get that, then you just add them straight up and down, and then look what happens. Oh, it eliminates. Oh, it's gone when I add them straight up and down. 20y and 21y make 41y's. 10 and 72 make 82. Oh, y is equal to 2. And then this is the annoying part. You got to plug it back in. I usually go back to the originals, but it's not that hard. I'll do it into the bottom one here. 2x plus 2 times 7 is 14 equals 24. So 2x equals 10x is 5. Okay, so your point of intersection is at 5, 2. Okay, so there's your 3 ways. You got to practice all of them. Graphing, substitution, elimination, all right? And then we're just going to real quick do an inequality because I want to make sure we know how to do this and use that shading part of your app, and we're done, sadly. Okay, now, here's the thing about systems of inequalities. Systems of inequalities have several solutions. And so what we do is we shade regions where they work. So we are finding all the ordered pairs that satisfy both equations. Or both, I'm sorry, both inequalities. Okay, which means we're finding overlapping areas that overlap. And I'm just going to do 2 of these real quick, and we'll do them in your calculator just to refresh you on that one. So here's number 4. Y is greater than or equal to 1/2 x minus 3. And y is greater than or equal to 3x plus 4. Okay. And again, I'll let you use a calculator, but I really shouldn't. I want you to know how to graph these, but we've got to learn how to do the calculator because it does help us out sometime and make it a little bit quicker for us. Okay. Make sure your Inequal-Z app is on. So again, you go to apps and hit Inequal-Z. If your calculator doesn't have that app, I'll try to get it on to yours. Not yet, but we'll get it on. Let me go back into Y. And the way that you do it now, everybody's calculator is differently. Hopefully Miss Davis taught it to you. But the way you do it is you put your cursor so that it's flashing over the equal sign, and you hit alpha one of these. So I have a greater than or equal to, so that would be alpha graph. So alpha, this last one, and it makes it greater than or equal to. If you have the skinny flat calculators, oh, what do you have to do with that one? I think you have to arrow all the way over. Yeah, Andrew?
You just press on it and then you click which one.
You press enter on it and then you can click which one? Yeah, I think it's something like that. All right, so then we hit, now you type it in, 0.5x minus 3. We're going to do that again for this one. So this is less than, so I want alpha window. And that would be negative 2x plus 7. And then watch how long my calculator takes to do this. That's right. We're here all day. It's coming. Here you go, honey. You can do it. Boom. Okay. Want you to notice something. This line is dotted or dashed. Do you know that? Mm-hmm. This line is solid. Why is that? Good job. Okay. This point right here is the point of intersection. That's the point they have in common, but they also have where the overlapping occurs. Where's the overlapping occurring? right here. Your calculator will actually, I don't know if you noticed, it'll actually just shade that overlapping. I would do it here, but it's going to literally take forever. If you hit alpha y equals, it'll shade the intersection. Watch how long this takes. Just watch how long it's coming. Anyway, then you graph it, dash, 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 and you give to me the shaded region that they overlap, okay? And you don't write out every answer. There's an impossible, there's so many answers, you can't write them all out. Because this is an answer. I hope you understand, like this is an answer, this is an answer, this is an answer. Do you all agree, right? There's no answers over here. There's no answers over here. It's only where it overlaps. There's so many answers. You don't have the ability to write them all out. Look at what it does. There it goes. And by the time I'm finished, it finally shaded it. See, look at there. Okay. So let's do this one now. Well, actually, I want you to notice something about this one. These two lines are what?
Parallel.
Oh, so either they're going to have the overlapping in the middle or where? Okay. If it's in the middle, cool. If it's on the outside, not cool. So let's just see. I bet you could do this without the calculator. I'm actually going to do this without the calculator. Here's why. This is at -8. Here's -8. You would go up 3 over 1, up 3 over 1, up 3 over 1, and you make a dashed line. If you are less than, would you shade above that line or below that line? Below. So this way. For this bottom equation, you go to 4 and you do the same slope, and it's a solid line. And y is greater than, so would you shade above or below? What's happening here?
Don't match up.
They don't match up. There's no overlapping, so your answer would be? Good job. All right, and you can do that on the calculator if you want to. That's it, kids. So the rest of this time, you are either going to make corrections if you want grades back. You can start your work from the home. Page P22, 1, 3, 6, 7, 11, 13, 15, 17, 19, 37. 40. That's not bad. 2, 4, 6, 8, 10, 12.